right, here we have another one. I'm going to check the time, see how we're doing. Perfect. All right. Ooh, here we are into rotations. So, rotate triangle ABC 180 degrees around the origin. Where is C prime? So, to rotate the shape, I'm literally going to take that and flip it. So I know it is going to be completely on the other side, facing the other direction, completely upside down. I'm going to get my new locations. So I will show you how to do C first, then we will fill in the rest. So instead of going over 2, down 1, I'm going to go over 2, up 1 to get a 180 degree translation or reflection. Rotation. I'm going to say the wrong thing every single time. So now I'm going over 6, down 1, so I'm going to go over 6, 1, 2, 3, 4, 5, 6, up 1. And instead of going over 4, up 5, I'm going to go over 4, 1, 2, 3, 4, down 5. And if I need to know where C is, that was that first one that I translated. Let's see if I'm right. Yes. All right. So C prime was at 2, 1. It was at -2, -1. But remember, you negate those. So it's the opposite of whatever that was, +2, +1. That is how you get your rotation of 180 degrees on there. We have another shape. Well, same shape. Because Miss Monroe likes dealing with triangles because there's only 3 points. It makes it a little bit easier than translating like a shape with like 5 points or more, or circles. Circles are difficult, but that's okay. We won't get into circles. We won't get into circles too much this year. That's later. That's more calculus type stuff. We will get into trig though, which is triangles, but it's also the angle measure and it ties into circles in a little bit. So we will get there, just not quite yet. All right, so here we are, reflecting again. Reflect triangle ABC over the y-axis and then over the x-axis. So here we are taking 2 rigid transformations. So it's just a reflection and a reflection. So essentially, I'm taking the shape, reflecting it, and reflecting it again. So you should get a shape that looks kind of silly compared to this one. It'll be in a weird spot. So we will talk about how to do that right now. But this is what you call a compound transformation or a composition of transformation, which just means many transformations. I know, math can be confusing because we like to make up words for things that already have words that are easier, but math is older than modern English. Math is older than modern English. Isn't that weird, guys?
Oh.
I think that's really weird. Math is actually originally Greek. The first original written mathematics, here's a little mini history lesson for you. The first written documentation of mathematics is, well, debated where it was found, but it is in ancient Babylonia or ancient Egypt. So if you know that region, math, the first written parts of math came from Babylonia and Egypt. That might pop up as a extra credit question somewhere because I think it's really cool. Anyway, I should get back to work and help y'all figure this out, right? So, compound transformations, that is multiple transformations done on the same shape. So here we have our first shape. Reflect a triangle ABC over the y-axis. That is this up and down one. We've already done that. We've done that a couple slides ago. So let's look at that. Instead of left 2, I'm going to go right 2. So here's C prime. I think it should be asking where is C prime prime, double prime, because that's our second transformation. I'll show that in a second. A is going to be negative 1, 2, 3, 4, 5, 6. Yes, I have to count every time because I forget. 1, 2, 3, 4, 5, 6, negative 1. All right, so that is my A prime. Again, I apologize for the handwriting, for the clicky mouse writing. I just can't write on this mouse. All right, and last but not least, 4, 5. So here I go. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That doesn't look in the middle. Yeah, it is. Okay, it just doesn't look in the middle. Sorry, my bad. Up 6. That is B prime. And then it says, then reflect over the axis, the x-axis. So that is going to be that flippy floppy reflection again. So I'm going to take this new shape, which I'm not going to bother drawing the lines. Yes, I will. That is my attempt at drawing on the mouse. This is why I need to use my tablet that I didn't hook it up this morning to the Wi-Fi. Yeah, anyway. So reflect over the x-axis. Instead of going down one, I'm going to go up. That is C double prime. Here's my A. I'm going to flip that. I wish I could change the color, but I don't know how to do it on this type of presentation. This is a PowerPoint. I haven't used PowerPoint in a long time. Instead of going up 1, 2, 3, 4, 5, you're going to go down 1, 2, 3, 4, 5. That is B double prime. And then you have this funky looking triangle down here. And it asks where is C, it should say C double prime. Oh, they didn't do both, they just did the one. All right, so there you go. That is exactly that. This is kind of interesting though, guys. Look at this. Is that not the exact same location that the 180-degree rotation was in? So is a rotation just two reflections? Sometimes. I find it really interesting. So C prime, or C double prime as it probably should be referred to as, because you should have all of your images correctly written on your graph, just to kind of double check yourself. C double prime is at 2, 1, much like C double prime in the, or C prime in the 180-degree rotation was at 2, 1. So a 180-degree rotation is the same as a reflection over the x-axis and the y-axis. It does the exact same thing to a shape. Interesting. Here we go. Rotate triangle ABC 90 degrees counterclockwise around the origin. Where is A prime? So, rotating, oh, I found out how to change the color. But this one is not a compound transformation. This is just a transformation, a rotation. So 90 degrees counterclockwise. That is the opposite way of a clock. My reflection is mirrored, so I have to go clockwise to look counterclockwise to you. All right, so instead of going down over 2, down 1, I'm going to go down 2, over 1. Ooh, okay, that one is C prime. Instead of going over 6, down 1, I'm going to go down 1, 2, 3, 4, 5, 6, over 1. Here is my A prime and B prime. Instead of going over 4, up 5, I'm going to go down 4, over 5. 1, 2, 3, 4, 5. I think a lot of the times it is easier just to have that stuff there for you, like to kind of go over it this way instead of remembering those algebraic rules. But it is important to know those algebraic rules. I just like showing you guys how I figure it out graphically. So there I have my points. Point A was at 1, negative 6. So I rotated it, took the triangle, flipped it, spun it. turned it. That's the word. All right. Ooh, here we have a tricky one. Reflect triangle ABC over the y-axis and translate it 3 units down. So, I'm gonna do that one for you. How do you get it to go? It just showed up. Okay, it's not going away. If I go back, it's still there. Okay, that's okay. So I'll show you how we got that. So reflect triangle ABC over the y-axis. So when you take it and you go 1, 2, 3, 4. All right, remember y-axis is going up and down. So it's 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 3 units down. So I'm going to go 1, 2, 3. 1, 2, 3. So this is my C prime, B prime, 1, 2, 3, A prime. So where is C prime? So as you can see right there, C prime is 2, negative 1, 2, 3, 4. 2, negative 4. It's like the triangle forgot to disappear there. That's it. It worked. All right. That is all we have for this one. I hope that that helped you guys. Kind of going over some practice problems on rigid transformations as well as compound transformations. All right,